Hello and welcome to Advent of Code, day 4, December 4th. Welcome everyone. We're getting ready to start the 4th programming challenge. Very excited about this. Gonna refresh the page. We got about 16 seconds left. Very exciting. About 10 seconds left to go. Let's see what kind of problem they've got for us tonight. Here we go. All right. Let's see. All passwords must be a passphrase, passphrases, etc. No duplicate words. Okay, given an input, how many of them are valid? All right, so let's save this to some input. All right, and then we know that we got a function that is going to be capable of parsing this here. Let me see if I can find it. All right, well, we're going to slurp temp input.txt. This is going to represent it as a list of lists of words, and then we're going to filter by no duplicates here and then count it. All right, and then our implementation for no duplicates, given a list of words, is going to be, is it the case that's equal to the set of this, the count of the set of this here? Count. All right, and it doesn't know what I meant when I saved this here. Okay, looks like it's saved to my home directory, so home W Morgan. And here we go. It doesn't know what it means by that either. All right, so let's save here on the directory temp. All right, temp input.txt. All right, count is not supported by on input. Okay, right. Looks like I have to actually parse this thing using my parsing function. And then the answer says it's 477. So let's try 477. The answer is the right answer, rank 100. All right, here we go. And let's see, for added security, put in place, let's see, no two words that are anagrams of each other. Okay. All right. So in this case, no duplicates becomes sort of like no anagrams. Anagrams. Go. And we're going to have to filter on this. All right. So what we got to do, I would say, for each of these words is we got to map the frequencies to it. And then I would guess put this into a set. I would say put it into like some kind of set. That seems kind of right to me. Question of whether it's equal to the count of the words, something like this. And then if we asked no anagrams for something like A, B, and BA, if our inputs were like a vector like this here, need to close the thing here. And then no anagrams is false, but ABA, okay, so it's still false here. Okay, map frequencies into a set. Let's see. So map frequencies into this thing, into a set, and then the question is, oh, right, so we got to do a count here. Okay. Okay, no anagrams is true here, but no anagrams is false here. All right, 167 is the answer. All right, the right answer, rank 96. Okay. All right, very quick night for this night's Advent of Code. Let's take a look at our Advent calendar in the first case. All right, and it seems like more of the same. Doing a couple of refreshes here to sort of get a general sense of the thing. Ooh, all right, very intricate patterns possible here, depending on I guess what kind of random seed you get. Very interesting stuff. Yeah, let's talk about the problem a little bit. All right, so going back. Let's see how long it took. The first okay, so the first answer was gotten in 37 seconds. Very impressive. And the both sides were gotten in a minute and 10. All right, very interesting stuff. Let's go to the problem statement. How do I get there? All right. Okay, so basically these are passphrases, and the question is, make sure that in your input that it is not the case that any of the words in the passphrase are repeated. So that's part one. So it gives us this input here. If I copy this to my clipboard and maybe ask Bash, how many lines are in it? The answer is 511. It might be 512, depending on. Yeah, it looks like 512 lines. Looks like there is not a trail new line, which is why WC has some different kinds of inputs. All right, so 512 lines, and then the question is, of those lines, how many do not include a duplicate line? In our implementation, my implementation was, let's see, so something like I think I called it no duplicates, and then that was basically, to take WW, which is a sequence of words, and to make sure that there are no duplicates in there. So I think that my implementation, if I could just maybe reinvent it right here, no duplicates, like this, given a WW, was the question of whether it was the case that the set of words in the input, or rather the count of the set of words in the input, was equal to the count of the input. And a function like this has a characteristic that if you feed in, let's say 1 and then 1, 1, 111 like this, then the answer, and it wants an actual list as input. So like this, no problem. Let's see, so no duplicates here. What is the difference here? Okay, so we have a list containing 1 and so it would be more like there. All right, so in this case, if the input to our function was 1, 1, and 11, then the answer is false. If our answer was just 1, 11, then the answer is true. Basically, it's saying use the closure function set here, which takes a collection of things and returns a set on them, which basically uses the equal semantics to produce a set object here. And then if we had, something like 1, 2, 3, 4, 5, all right, then this still returns true. But if we introduce another 5 in here, then it starts to return false. And the reason for that is that this set in here that we made was that this would end up having a lower count than the count of all the words that we got here. All right, so pretty straightforward stuff. And then the second part of the problem, which is where I think if I look at my actual stats, I think I did better on day 4. Let's see here. So it looks like on step 1 I was in 100th place. But on step 2, I was in 96th place. Not a huge difference, but I think that closure makes it a little bit easier to solve this kind of problem, which is to say that we don't actually care about the words being the same. We care that it's never the case that there are no anagrams of words. All right. So how do you represent an anagram? And then what I decided to do is I decided to use the closure function frequencies. So frequencies, if you're not familiar, you pass it in a collection, for example, 1, 1, 2, 3, 4, and then it returns to you a map of each of the elements in the collection mapped to the number of times that it occurs in that collection. So in this case, you can see here it's returning 1 is mapped to 2, 2 is mapped to 1, 3 is mapped to 1, and 4 is mapped to 1. The number of times that it occurs in that collection. And this is an adequate way to represent an anagram. If you had especially large collections or you had to be doing this kind of thing frequently for a lot of like different strings, then you might want to use a solution that, say, represented each of the input elements as a different prime number and use multiplication, taking advantage of the, what's it called? The fundamental theorem of algebra, I think. But in this case, it's quicker to write something that's quick in code to just solve the problem. So in this case, we use frequencies. So we said, basically, the implementation, no anagrams, says that for each of the words in the input, we're going to map the frequencies of it. We're going to put it into a set here, which is this is just an empty set. So we're going to insert the elements into a set. We're going to take count of those things, and then we're going to compare to the count of the things to begin with. And then if that is the case, then it should be the case that we should be able to do a count of no anagrams on this thing. And you can see here that if we had the inputs AB, BA, then the answer is false. If we had AA and AA, the answer is true. If we added CC, then the input is still true. But then as soon as we introduce, like, say, AA, okay, then it becomes false. Or BA, then it becomes false. So yeah, and then our answer just becomes take the input and do this kind of thing, do a filter on no anagrams. So that's it. Very quick kind of solution. Quick day. I was glad that we were able to get a couple of points, although I don't know how that makes us compare to everyone else. So it seems like in order to even appear on the top 100, we need 132 points here, and it seems like we got so this would have been about 5 points here, and then 1 point here. So we got 6 points today, plus all the points that we had gotten so far. So I'm not sure where in particular we can find that in our stats, but I think it means that we have to be doing better tomorrow. So I'm going to do my best to do better tomorrow, and that's about it. I'm glad that this night was pretty straightforward, and thank you for watching. We got a great Advent calendar going on here, and that's it. Hope to see you tomorrow.